Name all three sides and all three angles of this triangle. Make sure to follow the conventions. All right, I can do that. I'm going to call this one K. I'm going to call this one L, and I'm going to call this one M. Notice I use capital letters because those are angles. All three sides. All right, so this 54 over here, that's going to be little m because it's opposite to big M. This 45 will be little l because it's opposite to big L. And this will be little k. So I use all three the same letters, but they're lowercase because they're side length. All right, so I followed all the conventions. That's great. Now I want to find the missing side length and the missing angles, show all of my work, and communicate it using mathematical conventions. Okay, I can do that as well. All right, I'm going to do it in blue. All right, the first thing I always look for is, do I know two angles already? I know the 71 degrees. I don't know another angle. Okay, so I'm not going to use that equation where I say, angle L equals 180 degrees minus 71 degrees minus this, and then find L, because I don't know what this is. I need two angles to do that. Next step, do I have an angle and a side that are opposite to each other that I know both of? So 54 and 71. Yeah, I do. Okay, so sine law. Definitely use the sine law here. Sine law says the sine of that angle, 71 degrees, divided by the side, which is 54, is equal to, notice I put degrees here, right? Because that's the only kind of angles you guys know about. So it's just to tell the reader that we're talking in degrees and we're not talking in some other type of angle like radians. All right, now I've got my angle and side together, the ones where I know both of them. Now I have to find an angle or a side where I know one but not the other. Right? So it's like, here's 45, I look opposite to that, and I don't know L. That's perfect. I know the side but not the angle. So I'm going to use those two for the other side of my equation. I'm going to say sine of the angle is capital L divided by the side, which is 45. And this is great. The reason I did it that way is so that I don't have any variables on the left, because I knew both of these. I knew the side and the angle, and I have one variable on the right, so I have a total of one variable. And now I can rearrange this. This 45 goes up here to the top. Notice I didn't put it on the bottom with the 54. I put it up to the top. And I could just put all this in my calculator. This will equal sine L. So 45 times sine 71 divided by 54, 0.7879. The next number is a 3, so it's going to be rounded down to 9. And that's approximately equal to sine of L. I did expect a number to be between 0 and 1 here. That's normal because it's not L that we found yet. We found sine L. We have one more step. So to find L, we need to take the sine inverse of that number. And it's approximately 52.0 degrees. So it was actually 51.9, and then the next number was larger than 5. So I had to move that 51.9 up to the next one, which is 52.0. 52.0 degrees. I can now put that in here, 52.0 degrees. All right, now I'm going to start over. First thing I always look for is, do I know two of the angles? Exactly two of the angles, and yes, I do. So now I'm going to use that equation that I was talking about earlier. Change the color and say K, which is the angle I'm looking for, is equal to 180 degrees minus 71 degrees minus 52.0 degrees. So K is equal to 57.0 degrees, and I can write that in there. All right, so I've got all three angles now, and I've got, let's see, I've got one side, I've got two sides. I still need that third side of K, so let me go for that. First thing I look for, I start over again because I found another side. Do I know exactly two angles? Not anymore. I know all three angles, so I can skip this equation. That's always the first equation I try. Second equation, do I know a side and an angle where I know both of them? Well, yeah, it's still the 71 degrees and the 54. That means I could solve using the sine law again. All right, so sine law. Do this one in green. We're going to say the sine of 71 degrees divided by 54 is equal to the sine of, now I need to find, so that's, I know both the angle and the side there. I need to find a side and an angle where I know one but not the other. So I've got my 45 and my 52 degrees. Well, I know both of those. That's not going to be helpful, right? That would have been helpful for the left side, but we already have one with both. The one where I know one but not the other for the right-hand side is this. So 57.0 degrees, and I don't know for K. So sine of the angle, which is 57.0 degrees, divided by the side, which is K. The variable's on the bottom, so I'm going to switch this equation. I'm going to say K over sine of 57.0 degrees is equal to 54. I'm going to put the sides on the top and the angles, the sines of the angles on the bottom. That way my variable is on top where I want it. Now I can cross this sine of 57, sine of 57.0 degrees, and put it up top here, not at the bottom, but at the top, on the same level as the 54 and the K. And now I can simply find what K is. So sine of 57 degrees times 54 divided by sine of 71 degrees is about 47.9. This is not degrees, this is a side length. So 47.9. And now my triangle is solved. Notice I always try to use this equation first if I have two angles exactly. If I don't have two angles exactly, then I always look for an angle and a side where I know both of them. If I have that, then I'm definitely using the sine law. All right, next triangle. We have our 68 degrees here. We have 63 degrees, 458.2 here. We need to know this angle and these two sides. Name and solve the triangle. Well, let's name it. Okay, let's go M. Let's say N. I don't like to use O because it looks too much like a zero, so we'll do P. All right, step one, and I'm going to always ask the same question first. Do I know exactly two angles? Well, yeah, in this case, I know 68 and 63, but I don't know N, so yeah, I know exactly two. All right, let's use the equation to find N. So I'm going to say N equals 180 degrees minus 63 degrees minus 68 degrees, and that means that N equals 49 degrees. I can write that in. Okay, I'm done one angle. Anytime you find an angle or a side, you start from scratch. So my next thing, change the color here and say, do I know two angles? I always say that. Well, no, this time I know 1, 2, 3 angles. So I can move to the next question. Do I know an angle and a side that are opposite to each other? So, oh, look at, I know this 49 degrees and its opposite side, 458.2. So yeah, I actually do know that. So let's use the sine law, because when you know this, when you know an angle and its opposite side, you're definitely going to be using the sine law. So sine of 49 degrees, sine always goes with the angle, and the side goes by itself, is equal to sine. All right, on the right-hand side, what do we need? We need one angle or one side, but not the other, like not its opposite. So you have to find, so here we have 63 degrees. And we don't have this little p here. Well, I did forget to name this little p and this little m, didn't I? And then this would be little n. All right, so we do know big P, but we don't know little p. That's perfect. On the left-hand side, we do want to know both. We know big N and we know little n. On the right-hand side, we want to know one, but not the other. And that's the case right here. So this is perfect for us. So we can say sine of 63 degrees over little p. Okay, the variable does happen to be on the bottom. So I probably should have done it the other way around with the sides on top and the sines of the angles on the bottom. So we say 458.2 over sine of 49 degrees is equal to p over sine of 63 degrees. And as we all know, this guy on the bottom comes up not to the bottom, but to the top, 63 degrees. And you want to write it in such a way that it's on the same level as this 458.2. Don't make it an exponent. Don't make it up too high. Don't make this all of a sudden smaller than the rest of the stuff. Don't make it a little mini sine 63 degrees. put it right next to, it has just as much importance as the 458.2, and it's on the same height. The sine of 49 degrees is on the bottom. That should not be on the sine of 63 degrees should not be on the same level. It's got to be up top. All right, so now our P is going to be equal to, we just have to do sine of 63 degrees times 458.2 divided by sine of 49 degrees. That gives us approximately 540.9. Notice I didn't say equals exactly. I put these little squiggly lines for my equals to say that I did round. So 540.9 approximately is our P. 540.9. All right, I solved another thing, and I'm going to go right back to the beginning, just like I always do. Do I know two angles? Exactly two angles. Nope, I still know three angles. The answer will always be no once I know the third angle. All right, do I know a side and an angle that are opposite to each other? Well, yeah, I know the 63 and the 540.9. I also know the 49 and the 558.2. I'm going to use these two because this one is rounded a little bit. And if you use a rounded number, it's going to give you a little bit worse answer than if you use the two that are exact that were given to us. So I'm going to use these two. But if you use these two, you would get the exact same answer anyway, because the sine of 63 degrees over 540.9 is the exact same thing as the sine of 49 degrees over 458.2. We just proved it. They're the same thing. We just did that right here. Sine of 49 over 458.2, sine of 63 over p. They're the same. So you could either use these or these now that we know both sets. Okay, so let me use the one that I know is the most accurate. Sine of 49 degrees over 458.2 equals the sine. Now find the one where we know one but not the other. So I know 68 but not little m. That's perfect. The sine of 68 degrees, the angle goes with the sine there, sine of an angle, over little m. Little m's on the bottom. I should have done it the other way around. M over sine of 68 degrees equals, well, if the side goes on top here, and the side goes on top here, for them to still be equal. Right? They have to have the ratios just like that. The m is on top. This sine of 68 can come over here. We've discussed that a million times in class. Make sure it's on top. Don't put it on the bottom with the sine of 49 degrees, or you'll be wrong. Don't make it really small and up too high, or I'll think it's an exponent, or I'll just think it's some weird thing. All right, so put that in our calculator. Sine of 68 times 458.2 divided by sine of 49 degrees is approximately equal to 562.9, and that is m. Equals approximately 562.9. I have all three sides, all three angles, so I am finished solving this triangle. All right, first things first on this next triangle, we're going to name it. So let's call it PQR. Why not? Which means this is going to be little r, this is going to be little q, and it's going to be little p, right? Because opposites, right? This angle and this side are opposite, so P and P, Q, Q, R, R. The angles are always the capitals, and the lowercase are always the sides. All right, let's try to solve it. The first question I always ask myself, do I know exactly two angles? Well, no, I don't know any angles. So I will not use the whole, Q equals 180 degrees minus the two angles that I know. I can't use that because first I need to know the other two angles. All right, so the next thing, do I know a side and an angle that are opposite to each other? Do I know both of them? So I see that I know 608 for little r, but I don't know big R. I know little q, but I don't know big Q. I know little p, but I don't know big P. I don't know any set where I know both the capital and the lowercase. So I cannot use the sine law. The sine law is out. So is that one. All right, I guess we're using the cosine law. Now, there are two cosine laws. There's one if we're trying to find a side length. There's one if we're trying to find an angle. Well, in this case, we're obviously trying to find an angle. So we're using the one that looks like this. The cos of, let's say capital R we'll go for, is equal to p squared, 620 squared, plus q squared, 580 squared, minus little r squared, 608 squared. Notice the one that I'm subtracting is also the opposite to the angle that I'm using. Okay, that's the one that kind of sets itself apart. It's because it's opposite to the angle that I'm trying to find. Okay, this is going to be divided by 2 times 620 times 580. Again, the one that's left out on the bottom is the 608, which is opposite to this r. So the side that's opposite to this r has two things. It stands out on top because it's being subtracted. The square is being subtracted. It stands out on the bottom because it's the one that's not included. This 2 just always goes there. That's part of the equation. All right, so now I could just plug this all into my calculator. Okay, it's probably best to put brackets around here so that when you're using your calculator, you don't mess up the order of operations. So in your calculator, it's a good idea just to go open bracket, 620 squared plus 580 squared minus 608 squared, close bracket. There you go, divided by 2, divided by 620, divided by 580. All three of these are on the bottom, so you should go divided by that, divided by that, divided by that. And equals, it should come out to cos of r again, is equal to approximately 0.4882. Whenever you're doing sine r, cos r, tan r, make sure you don't just say 0.5 because you're going to lose the actual angle if you do that. I want 4 digits minimum after the decimal point if you want to get the correct angle when you solve for the angle. So now last step is to solve for the angle. This is probably not going to be exact. So to find r, you need to take the cos inverse of this number, and that's the problem. If you round it too much, then the cos inverse of that number will not be accurate. So this is going to be approximately 60.8 degrees. Now, just to try, if I had just rounded this number here to 0.5, and I took the cos inverse, I would have said just 60 degrees. So I would have been off by enough there, right? So 60.8 degrees. This is more like 61 degrees than 60, right? So it's definitely good that I kept all 4 digits here. All right, now I'm going to start over. I now found one of my angles. And anytime you find an angle or a side, you start from scratch. Do I know exactly 2 of the angles? No, I still don't. So this equation is not going to be helpful just yet. I only know 1 angle. Do I now know a side and an angle that are opposite to each other? Oh yeah, well I know little r and big R now. Little r is 608, big R is 60.8 degrees. Oh, that's a nice coincidence. That's just a total coincidence, 60.8 and 608. Anyway, so let's use it. All right, so we're going to say sine of 60.8 degrees over 608. I always use the 2 that I know on the left-hand side. Now, find one that you know, where you know the side or angle, but you don't know the other, like the opposite of it. So if I know the side, I can't know its opposite angle. If I know the angle, I can't know its opposite side. So I'm just going to look here. Little q, I know it's 580. Let's check to see that we don't know, and we don't know big Q. That's perfect. I know little q, but not big Q. Okay, so I'm going to write that in here. Sine of the angle, which is big Q, that's the one we don't know, over the one we do know, 580. Our variable is on top. That's good news. I don't have to switch it. This 580 comes from the bottom and you put it on top. There you go. And let's solve. So 580 times sine of 60.8 degrees divided by 608. And that is equal to approximately 0. Now, obviously, this is going to be equal not to Q, but to sine of Q. So I'm going to keep at least 4 digits. Whenever you have something equal to sine, cos, or tan, you want 4 digits minimum. So 8, 3, to 7. I check the next number, it's a 2, so I don't have to make this one an 8. If the next number were 5 or higher, I would move that up to an 8. All right, I'm going to keep that in my calculator to find Q. I'm going to do the sine inverse. And that is approximately 56.4 degrees. Q, 56.4 degrees. Okay, I found another one, which means I'm starting from scratch. The first question I ask myself each time, all together now, say it with me. That's right. Do I have 2 angles, but not the third? Just exactly 2 angles. And yeah, now I do. So now I can use my original equation that I wanted to use first, the one that I always ask about first. All right, so let's do it. This is P we're looking for, and that equals 180 degrees minus 60.8 degrees minus 56.4 degrees. And that, my friends, is equal to 62.8 degrees, which is P, 62.8 degrees. And we now know all angles and all sides. That means we solved the triangle. All right, new triangle, let's name it. Let's name this one L, M, and N. And make this side little l, little m, and little n. And we need to find capital L, we need to find capital M, and we need to find little n. And we already know big N, little m, and little l. All right, let's get started. I bet you don't know what I'm going to ask first. Yeah, you guessed it. Do we know exactly 2 of the angles, but not the third? I know one angle. I don't know another angle, so the answer is no. I will not be using the whole L equals 180 degrees minus 43 degrees minus, I don't know that other one, so this is not going to help. Okay. Next, do I know a side and its opposite angle? All right, well, let's look around. I do know a side here, 77, but I don't know its opposite angle. I do know a side here, but I don't know its opposite angle. I do know an angle, but I don't know its opposite side. So no, I don't know that, so I cannot use the sine law. Sine law is a no-go for now. All right, I know I'm using the cosine law then. There are only 3 things we need. This guy, and the cosine law. And the cosine law is definitely going to help. Now, this time I don't have to find an angle. I'm going to go and find this side. Whenever you have a situation where you're using the cosine law, if you can find the side, go for it. All right, so we're going to use the equation where you're finding the side. And obviously, we're finding n because that's the only side we don't know. We already know 97 and 77. All right, so let's do it. We're going to say n squared equals the other 2 sides, 77 squared plus 97 squared minus 2 times 77 times 97 times the cosine of big N. Okay, notice that your n squared is here and your big N is opposite there. Oops, I probably shouldn't have written cos of n because I know what n is. I know what big N is. It is 43 degrees. 43 degrees. Okay, so the side we're finding is opposite to the angle that's 43 degrees. All right, plug that all into my calculator to find n squared, and then I will just take the square root later to find n. All right, so 77 squared plus 97 squared minus 2 times 77 times 97 times cos of 43, and then you click equals 4,413.0 approximately. I'm going to keep that number in my calculator and just take the square root. It's approximately 66.4. So n is equal to approximately 66.4. Well, anytime I find a side or an angle that I didn't know before, I start from scratch. And I'm going to ask myself the question, do I know exactly 2 angles? Well, I know 43. Nope, I don't know another. So I'm not going to use this equation yet, the 180 minus. So do I know a side and an angle where one's opposite the other? Well, 66.4 I know now, and I know its opposite angle of 43. So the answer is yes, I do know a pairing. So I know I'm going to use the sine law. Let's do it. Fine. I'm going to use that pairing on the left here. Sine of 43 degrees over 66.4 equals, now I need to find an angle and a side where I know one but not the other. So I know 77 and I don't know its opposite, big M. So that's perfect. So we're going to say sine of big M, sine of the angle that we don't know, over 77. Our variable is on top. That's convenient. And so we can just get rid of this 77, put it on top over here, not on the bottom. Same size as all the other numbers. You don't have to make it smaller and higher or anything like that. Right on top with the sine of 43 degrees. And so now we're going to know what sine of M is. We won't know the actual angle yet. We're only going to know the sine of the angle, because we don't really use angles in the sine law. We only use the sine of the angle to make sure that it's the correct ratio. So we're going to do 77 times sine of 43 divided by 66.4 equals approximately 0. Now, since I'm doing sine cosine tan of an angle, I'm not just going to round it to one digit. I have to go 7909. And the calculator says 7908, but the next number is a 7, so that 8 became a 9. All right, so to find M, obviously, we need to take the sine inverse of that number. So I'm just going to keep it in my calculator, do sine inverse, and that's 52.3 degrees. I can write that down, 52.3 degrees. Now I found another side or angle. So now I have to go back to the drawing board and ask my question again. Do I know exactly two angles? Oh, well, this time the answer is yes. 43 degrees and 52.3 degrees. All right, so I'm going to use the easiest of all equations to find that third angle. L is equal to 180 degrees minus 43 degrees minus 52.3 degrees. So L is equal to 84.7 degrees. 84.7 degrees. And I have solved my triangle. All right, here's another triangle. Let's start off with naming it. Let's say it's a T, U, and V. And so this side will be little v, this side will be little t, and this side will be little u. Make sure that the opposite sides and angles are used as the same letter, and all the angles are capitals, and all the sides are lowercase. We've done all that. What's the first question I always ask myself? Do I know exactly two of the angles? Yeah, I know a 90-degree angle here and a 42-degree angle here, but I don't know this one. So we're going to go straight to my favorite equation to find u. That's going to be equal to 180 degrees minus 90 degrees minus 42 degrees. So that is going to be equal to 48 degrees. So I can write that in, 48 degrees. Okay, now the next question I ask myself generally is, do I know a side and an angle that are opposite to each other? And I do. I know 42 degrees. Oh, nope, not that one. I know 90 degrees and 17.6 degrees. So I could actually use the sine law here. I could go sine of 90 degrees over 17.6 equals, now I have to find an angle that I know but without the opposite side, or the side I know without the opposite angle. So I'm going to do this sine of 42 degrees over t. And we've gone through this many, many times in this video. We could solve this. But when I saw this question, I knew that I'm actually looking to try to prove that I can do SOHCAHTOA, right? So there are special ways of solving triangles if you know that there's a 90-degree angle. And here we do have this 90-degree angle. So I want to prove myself with SOHCAHTOA instead. I want to prove that I can use SOHCAHTOA to solve this triangle, right? And so SOHCAHTOA says if there's a 90-degree angle in your triangle, then you can say that the sine of any other angle, you just get to choose the other angle. It doesn't even matter which one you use. 48 degrees is equal to opposite. Now, opposite isn't just any side of your choice, right? First of all, you have to know which angle we're using. So since we're using 48 degrees, we have to do opposite, right? So this is opposite over hypotenuse. The sine is going to be opposite over hypotenuse. We have to find the opposite of the angle that we use. You can't just choose any side willy-nilly. So since we're using the 48-degree angle, well, then I have to find the opposite of that. So I can't use, so this is 48 degrees. I have to use U. I can't use T because that's not opposite to 48. That's opposite to 42. Now, if I had said sine of 42 degrees, which I could have done, well, then the opposite would have been T. But that's not what happened, so I can't do that. Right? So I'm going to say sine of 48 is opposite. So opposite of the 48 is U, divided by the hypotenuse, which is 17.6. Hypotenuse is always the side that's opposite the 90. Right? So here's my 90-degree angle. This is always the hypotenuse. Right, let's write down the other ones. That's the sine. We also know the cosine. I'm always going to use the same angle. And once I pick an angle, I'm just going to stick with that angle for the rest of the triangle. Right, so that way I know I'm going to keep the same opposite side as going to be opposite to the angle that I chose, and that won't change. The cosine is not opposite over hypotenuse. It's adjacent over hypotenuse. Right, so we still know the hypotenuse. 17.6, but this time we have adjacent, which is T, over hypotenuse, right? So AH stands for adjacent over hypotenuse. OH stood for opposite over hypotenuse. And tan, I'm always going to use the same angle for all of these, equals, now this one is opposite over adjacent. Okay, well the opposite of 48 degrees is U, and the adjacent is T. Now that I do that, next step is to look at these equations and see which ones have exactly one variable. Because to solve an equation, we're going to want exactly one variable. Well, this one's out. Tan of 48 degrees equals U over, there are too many variables. There are two of them. Sine of 48 equals, oh, this one only has U, so that's good. And this one only has T. So we could actually use the sine and the cosine of 48 degrees to find U and to find T. And then we solve the triangle. Okay, so sine of 48 will give us U, and cos of 48 will give us T. Let's do it. Let's go for sine of 48 degrees. I like to put over 1 because it makes it seem more like I'm solving the sine law, and I'm really good at solving the sine law. Look for my variable. It's on top. That's lucky. So I can get rid of my 17.6 and put it over here, just like I did with the sine law. Notice I keep it on top. Same size. I don't make it like a little mini 17.6. Keep the same size. I'm multiplying. And I simply put in my calculator 17.6 times sine of 48. I can say divided by 1 if I want. And that is going to be 13.1 approximately. That's what U equals. So 13.1. Now we could actually use Pythagorean theorem if we want, or we can use cosine. So you can say cosine of 48 degrees is equal to T over 17.6. I like to make this over 1 because it makes it look nice and even. Notice that my bottom is with the bottom, like they're at the same level here, and the top is at the same level as the top. I don't want to get messy and start messing that up because it'll mess up my equation. So 17.6, goodbye. This goes to the top, not the bottom. And we can say 17.6 times close to 48 divided by 1, and that is equal to approximately 11.8. 11.8. And I have solved my triangle. All right, here we have another triangle. Let's name it right away. Let's call it HIJ. That's fair. That makes this little j over here, little h right here, and little I right here. All right, so first question I always ask myself, do I already know two angles? So I know this, I know this 90-degree angle, but I don't know any other angles. The answer is no. So I will not be using that equation, h equals 180 degrees minus 90 degrees minus whatever j is. I don't know j, so that's not going to be helpful. All right. Now, I always ask myself, do I know a side and angle that are opposite to each other? And I do. I know this 90-degree angle and this 76 side. So I could actually use the sine law. But since I notice that this is a 90-degree angle, I say to myself, I think I need to prove my SOHCAHTOA skills to my teacher. So I'm actually going to stick to SOHCAHTOA for this. I'm going to say SOHCAHTOA is just to remind me of the equations. I'm going to say sine. I have to pick an angle, and it can't be the 90-degree angle. I have to pick either J or H. Okay, well, I don't know either of them. That's okay. I never said I had to know what the angle equals. I just have to choose one of them. So I'm going to choose sine of J. And that is going to be equal to opposite over hypotenuse. If this is J, then the opposite must be little j. And I don't know little j, so this opposite is little j. But I do know the hypotenuse. Hypotenuse is 76, the one that's opposite the 90-degree angle, as usual. Cos of j. Now, once I chose j, I'm just going to always stick with j. So cos of j is adjacent. Okay, well, if this one's the hypotenuse and this one's opposite, well, I know that little h must be adjacent. Oh, I do know little h. It's 55. So adjacent over the hypotenuse. Oh, I also know the hypotenuse, 76. That's convenient. Let's do tan. I always like to write all three out, and then it's easier to show you guys which one we're going to use. So tan of j is opposite over adjacent. So since it's j, the opposite is little j. And the adjacent is 55. There we go. All right, we have all three equations. Now let's look through these equations and make sure we have one with only one variable. Here we have big J and little j, too many variables. Here we have big J. Oh, we only have big J. This is good. Here, big J and little j, too many variables. So we definitely are going to use the cosine, and it's going to help us find j. Let's do it. Cos of j equals, well, in calculator, I just have to do 55 divided by 76. Now, since this isn't j, it's cos of j. Anytime you do sine j, cos j, tan j, you always want to keep 4 decimal places. 7, 2, 3, 7, approximately. So to find j, you just have to find the cos inverse, which is approximately 43.6. Is that an angle? Yes, it is. We did cos inverse, so 43.6 degrees. So I'll do a little erasing in here. And I can say that this is 43.6 degrees. Okay, anytime I find a side or an angle, I start from scratch and I ask myself, do I know exactly two angles, 43.6 degrees and 90 degrees? Yes, I do. Now I can go and use my equation that I like the best to find the other angle. H equals 180 degrees minus 90 degrees minus 43.6 degrees. And if I'm not mistaken, that will just be 46.4 degrees. Write that in here, 46.4 degrees. All right, now I just need to know little j. Okay, well, let's start from scratch. Do I know exactly two angles? Well, no, now I know all three angles, so I'm not going to use this equation. Next, can I use a sine law? Well, yeah, I can, but I'm trying to show off because I know this is a 90-degree angle. I'm trying to show off my SOHCAHTOA skills, right? So let's do your SOHCAHTOA. So sine of big J, oh, I can actually fill that in now. I'm going to take this big J, and I'm going to replace it with 43.6 degrees, because that's what big J is. Is equal to little j, right? Opposite over hypotenuse. Ooh, now instead of an x, this one I could actually use to find little j. I'm going to continue through here because this one has the same situation where if I erase this j, I can actually just replace it with 43.6 degrees. Now, this one isn't helpful at all because I don't have any variables at all. So let's not use that one anymore. Let's do this 43.6 degrees. Oh, I could also use this one to find j. Well, that's interesting. So I could use this guy or this guy to find j. Right? Well, let's do the one that's at the top because why not? Who cares? Equals j over 76. I always like to do over 1 just to make it look more like the sine law because I know how to do the sine law really fast. So I erase this 76, not because my variable's on top, and I put the 76 at the top, not the bottom. And I could say that j is equal to, well, I just have to do 76 times sine of 43.6 divided by 1, and it is approximately equal to 52.4. 52.4. By the way, I could also have done the Pythagorean theorem, right? I could have said 76 squared minus 55 squared is equal to j squared. Right? And I would have found j squared by doing this, and then I would have taken the square root, and I should have gotten the exact same answer. Right? And now this triangle is solved. All right, you're stranded on an island. You'd like to know how far it is to the tall building that you see across the lake. How could you stay on the island and figure out that distance using only a tape measure and a protractor? All right, the bonus later we can do how could you measure the height of that same building under the same circumstances. All right, let's check it out. All right, so what we do know is we can measure triangles no problem. Okay, so we don't have any measurements here. We have this, I'm stuck over on this island here. I can't measure anything across this lake. I can't measure any angles that are over here, but I can measure stuff on my side. So, well, if I can measure stuff on my side, let's start measuring stuff on my side. So I'm going to take the tape measure. I'm just going to maybe stand here. I'm going to walk over to here and measure it. So let's say I measure 150 meters. All right, so I know that I want to know the distance to this building. So let me go, oops, maybe I should have made a straight line across, and maybe I should have measured from here. So I'm going to redo that measurement. So instead of saying 150 meters, maybe now this is only 130 meters. Okay, so I measure 130 meters across. I can measure this angle with my protractor. Actually, if it's a 90-degree angle that I make, if I just walk to that right spot, then I can just make it a 90-degree angle. That makes life a lot easier for me. I can actually take my protractor and set it up so that one edge is pointing here and the other edge is pointing there, and it'll tell me that angle. So I can point it right at that building. Let's say that angle is a, well, let's say it's like a 50-degree angle. Right? So now, I actually know this is a 90-degree angle. I know this is a 50-degree angle. I know 130 meters. I can actually solve this triangle, which means I can find this length, and if I know that length, then I know the distance. I know that distance, right? So let's do it. So we've got, first things we look for, as always, is do I know exactly two angles? Well, yeah, I know 50 degrees and I know 90 degrees. So that third angle, I can say, let's name it. So B for where the building is, F for the first spot I started measuring from, and S for the second spot. Right, so let's say angle B is equal to 180 degrees minus 90 degrees minus 50 degrees. So angle B is equal to 40 degrees. There we go. Alright, so now every time I solve for one of the sides or angles, I always go back to start. Do I know exactly two angles? Well, no, now I know three angles. So I'm not going to use this equation again, that would be useless. Right, do I know a side and an angle that are opposite to each other? Yes, I do. So I know I can use the sine law here. Now, I actually have a 90-degree triangle though. So I'm going to show off my skills and use SOHCAHTOA. So let's see, sine of, might as well use the angle S. Could use either one, just don't use the 90 degree for SOHCAHTOA. Sine of 50 degrees is opposite, ooh, look at that, that's the side we're looking for, is little s, over hypotenuse, that's little f. I was thinking that this was going to be the equation we used, but the problem is there are two variables, so that's not the one. Let's keep going. Cosine of 50 degrees is equal to adjacent, that's 130 degrees, or 130 meters, sorry, divided by hypotenuse, f. Well, that's only one variable. That's good if I want to find the distance of f. Alright, so I'll keep that in mind in case another question asks me that. But now let's go to tan, see what that one gives us. Tan of 50 degrees. And that one's going to be opposite, which is little s. That's exciting. That's the angle that that's the side length we're looking for. Over, what's opposite over adjacent, which is 130 degrees. No, well, I don't know why I keep saying 130 degrees, which is 130. Alright, yeah, I like to put this over 1 because it makes it look more like our sine law a little bit. And so now these ratios, we have the variable on top, which is s. I can take out this 130, put it over here, make sure it's on top. And s is simply the tan of 50 times 130. And that means that s is approximately equal to 154.9. 154.9. Therefore, the distance from the building to this part of the island right here is 154.9. Now, if you really want to get technical, you can actually measure this distance to the edge of the island as well, and subtract 154.9, subtract this distance to get the distance from the edge of the island to the building as well. Okay, but you'd actually have to take the tape measure and measure what that distance is. Okay, bonus. So now I know the distance to that building. How do I find the height of the building? Well, I guess if you just draw this out, imagine this is the building here, and this is the lake, and this is the island over here. This is that one spot, F, where you measured from, and this is B, which is the base of the thing, and we know now the distance across is 154.9 to F. I'm still on the island here, so I'm still standing over here on the island, but I have a protractor, so I could actually put my eye down here and make my protractor one leg go that way, and one leg of my protractor point up towards the tip of that building, and I can measure this angle here. Okay, so let's say that measurement is, let's say, a 30-degree angle, like that. And I know that that building, well, I can assume that that building is standing at a 90-degree angle. Okay? So we have a triangle again, and I just have to find the height. Let's call that h. Alright, so it is a 90-degree triangle, so I'm going to use my SOHCAHTOA trick again. I'm going to say the sine of 30 degrees is equal to opposite, which is h, over hypotenuse, which we don't know. Let's call that L. Right, so this is no good because we have two unknowns. Well, let's try cosine of 30 degrees. Cosine is adjacent, 154.9, over hypotenuse, This one we have one variable, that's good, but that's the variable L. I don't really care to find L. I don't want to know the distance from here to here. Now, of course, if I give you another question that said, hey, I want a string to go from the top of this building down to here, how long does that string have to be? Well, then, yeah, you would want L. Let's try tan. Tan of 30 degrees is equal to opposite H over adjacent 154.9. Now we have an equation with one variable, and it's the variable we're looking for. It's 154.9. I like to put that over one. Goes over here, 154.9 times tan of 30. 154.9 times tan of 30 equals, so H is equal to approximately 89.4. So we can say that the height of the building is about 89.4 meters, because we measured in meters. Alright, so there you have it. So if any time I'm asking you to find distances of unattainable things, it's no problem. Just measure things that are attainable. Right? So the first thing we had was an island and something over here that we couldn't reach, but we could draw a line on our own side and we could measure that. That's something that's attainable. And you can find an angle here and here, because that's attainable. If you have only one side of a triangle and two angles of a triangle, well, then you're going to easily be able to find that third angle of the triangle, and you can easily find those two sides. You have enough information to know all the rest. Alright, that's how we can know the distance to stars. Right? That's how we can know the distance to anything that's far away. Right? So anytime you need a distance of some sort or an angle of some sort, just measure the stuff that's near you and see if you can make a triangle and calculate the rest of it. Alright, that's all. If you need to be retested on this, there are plenty of real life examples I can give you, but hopefully that helps you.